Good morning everyone. Today we shall discuss about capacitance of parallel plate capacitor when a conducting slab is introduced between the plates. For this we need to draw a very simple diagram. We need to draw two parallel plates having uniform charge density, one with positive charge and other with negative charge. We imagine that the separation between the plates is D. Let the cross-sectional area of each plate, we consider it as to be A. So as per the topic, we need to introduce a conducting slab between the plates of the capacitor. So we introduce a conducting slab, say of thickness T. So this is the conducting slab of thickness T, such that this thickness should be less than the separation between the two plates. So here we have two region. The region this is filled with air, and that is, it occupies the space D minus T. Space is filled with air and T space is filled with conducting slab. And one important point to be noted here, as we have discussed before also, that E inside a conducting slab is 0. So as there is two charges, because of these two charges, opposite charges on the plates, a potential difference will be developed, and the expression for potential difference, as we know, it is given by E naught into distance, and here distance is D minus T for air, plus there will be one more electric field because of this conducting slab. But as we know that electric field due to conducting slab is 0, so the expression will turn out to be E naught D minus T. E naught D minus T, where this portion we have taken as to be 0, since electric field inside a conducting slab is 0. Also we know that E naught, that is electric field, is given by sigma by epsilon naught, and this surface charge density sigma is given by Q by A, where A is cross-sectional area and Q is the charge on the plates of capacitor. So we get the expression of E naught to be Q by A epsilon naught. So substituting here, we get V naught equal to, in place of E naught, Q by A epsilon naught D minus T. We get the expression. So this is the expression for potential difference between the plates of capacitor. But our topic demands that we need to find out the capacitance. So from definition we know the formula for capacitance is given as C is equal to Q by V. So this expression Q, the substituting from V from above equation, we get Q D minus T by A epsilon naught. Q common term gets cancelled, so we get A epsilon naught D minus T. So this is the final expression for capacitance of a parallel plate capacitor when a conducting slab is introduced between the plates of the capacitor. Now let's discuss a special case. What happens when T is equal to D? What is the meaning of this? It will be better to understand diagrammatically. So these are the plates of a capacitor. One charged with positive and other charged with negative. As discussed, separation between the two plates is D. Now as per our criteria, as per our requirement, we need to insert a conducting slab which will occupy whole of the space between the plate, that is T has become equal to D. So let's apply this condition in the expression which we have, A epsilon naught by D minus T. This is the expression, so we will put A epsilon naught in place of T. In place of T we need to introduce as D, so it becomes D minus T, and this becomes A epsilon naught by 0, and all of we know that A epsilon naught by 0, anything divided by 0 turns to be infinity. So the very important conclusion what we are getting, that capacitance of capacitor, the ability of capacitor to store charge becomes infinity when the space between the two plates is filled with an conducting slab. So this is important conclusion which we are getting from this topic. So what we have learned, let's take a quick review of that. Today we started with the heading capacitance of parallel plate capacitor when a conducting slab is introduced between the plates. For that we need to draw a simple diagram, two plates, one with positive charge, another with negative charge. Separation between the plate we have regarded is as D, and we have, as per our topic requirement, we have introduced a conducting slab of thickness T. Important thing here, we have noted that the thickness of the slab should be less than the distance between the two plates, and there will be two regions, one filled with air for region D minus T, and for thickness T it is conducting slab. We have learned in past that electric field inside a conducting slab happens to be 0. So as there is two charges on either of the plate, so there will be a potential difference. An expression for potential difference will be because of air and because of the conducting slab, but we know that for conducting slab electric field is 0, so in the next expression becomes E naught D minus T. Now substituting the value for E naught happens to be E naught Q by A epsilon naught, so we get the expression for potential difference between the two plates. Now as per our requirement, we need to find out the capacitance of a capacitor. The expression for capacitance of a capacitor is given by Q by V. So substituting the value of V from the above expression, we get the expression A epsilon naught D minus T, which is the final expression. So let's think what happens when the whole of the space between the uh, plates of capacitor is filled with conducting slab, that is mathematically it happens to be T equal to D. Then substituting for T equal to D in the above expression, we get capacitance of capacitors to be infinity, that is the capacitor has the ability to store infinity amount of charge when the space between the plate is filled with an conducting slab. Hope you have understood the topic. Thank you.